and welcome to this webinar, Your Brain and Music. And I'm sure our team is recording this for posterity as well. This is in honor of Dr. Krishnamurthy Srinivas, my late father, who was a well-known neurologist, probably known to many of you, and who had an abiding interest in music. In as much as he had an interest in neurology. So I think it's extremely appropriate. And it's wonderful for me also to be doing this again with Professor Michael Trimble, a very eminent, world-famous neuropsychiatrist with many, many publications and books over the years, running into the hundreds. Professor Trimble has focused on an area of neuroaesthetics in the last few years. And one of the results of that has been a series of books. I'll show you a couple of examples. This is one which I like, Why Humans Like to Cry. And this is a later book, The Intentional Brain. I'm, of course, yet to pick up Death in the Opera, which is one of his more recent offerings. And Professor Trimble, as a neuroaesthetic expert, is also interested in the links between creativity, human emotion, the brain, and life experience. And today's presentation and discussions on your brain and music are going to be linked with all this. Prof, great to have you on this program. Welcome. And it's the second time I think we are doing a webinar on something to do with neuroaesthetics.
Well, hello, Krish. First of all, it's wonderful to be back with you again. And I have very many favorable, lovely times when I've been with you, both in Chennai and in other places in India, but also with a wonderful time that we had when you were in London. And thank you very much for this invitation. It's an area which probably when we knew each other very well further back, you didn't think I'd be venturing into. But there are various reasons why I've been doing that, and I'll let you know. But first of all, Nigel Osborne, who is very central to work that he was setting up with you and also with me and in the field of music therapy, is in the Ukraine. Nigel is a philanthropist, he's a composer, he's a wizard with electronics, he developed something called the X System. And just to let you know the kind of thing that he's doing, he sent me an email a couple of months ago saying how terrible it was working, but he was doing his very best in the Ukraine. And he was treating traumatized children, in brackets, they're all orphans, close brackets, and traumatized soldiers. And there he is now, and I doubt if he could even get an internet connection. So I was hoping he would come. He said he would love to, but apologies.
Fully understand, Prof. I think the work he's doing is so wonderful that, it's just great that we are all associated with him and we all wish him the very best. Prof, I think we said in the order of things, we'd have you do a presentation first, and then we'll launch into a conversation. So I'm going to request Jackie to help you share screen, and then we can start the program, the lecture itself. Thank you, Jackie.
Thank you. Yes, thank you, Jackie. Right. So the title relates to your brain and music. And I just wanted to give a little bit of a presentation. First of all, I just want to introduce you to something called the Mozart effect. Now, this was the result of a paper by a man called Rauscher in 1993, where he played a piece of Mozart's music, K448, to a group of, in inverted commas, normal people, and was able to show that after listening to the music, people did rather better on intelligence tests than they did if they didn't listen to Mozart's music, but were listening to something else. Well, this went, as they say, viral, and it was such importance at the time but some people suggested that if you want your baby and infant to be much more intelligent, they should listen to Mozart. So the Mozart effect has been shown to be relevant, as I'll come back to in a moment. But the idea that music through, for example, Mozart style music could alter your brain activity became very important. And when I do talk to people about music therapy, people say, oh gosh, how does that work? Does music affect your brain? Well, of course it affects your brain. We all know that. Why is it so important that we have this capacity and maybe others don't? What you can see here is that monkeys and some of the greater apes actually have very limited capacity for working memory. We have, of course, an excellent working memory capacities. Chimpanzees can drum and display with synchronized tapping, but it's not clear that this is motor entrainment in the sense of becoming linked to rhythms. Oddly enough, the way they find out whether chimpanzees liked music was to put them in a large cage and have music one end and silence in the other. The music that the chimpanzees did appear to be more interested in was non-Western music. I'm not quite sure really how one can make of what one can make of that. Now, the human response to music, I don't need to go through the anatomy and editing very much, but on the right-hand side of the slide, you can see here the brain volume in all of the primate species. And here is Homo sapiens. And here is the temporal lobe of the same species, again with Homo sapiens. And it's quite clear that amongst other parts of the human brain, which has become increased in size and connectivity is going to be very important, size and connectivity, the temporal lobe structures turn out to be very important. Now, there's some controversy about what the music that we listen to, how is that developed by our natural development of the brain as through evolution, or is it purely learned by social exposure? Well, pitch is exploited by most of the world's music. The octave is it's a fact of nature, and it's a feat of nature. And most of the world's music is in fact constrained within the octave in various ways, divided and split up. The structural constraints of the human auditory system are obviously also important, but when you look for harmonicity, you're following, for example, a trail of harmonicity in the brain with, for example, EEG, you find it's in an embedded function in Heschel's gyrus, which is, of course, the main receiving area for auditory input. Frequencies of original sounds are transduced to similar frequencies, and the area of the inferior colliculus is actually referred to as a midbrain sound center. So music is traveling quickly into the central nervous system along well-defined pathways. And I just put another couple of other aspects as to how this then spreads into the auditory striatum. Now, a lot of people think the basal ganglia are purely to do with movement. Well, they are, but they have auditory input. And then there's the limbic and auditory cortex responding together with particular frequencies that allow us to enjoy the emotion which is embedded in music with pitch, timbre, rhythm, and entrainment. The amygdala comes into everything that has to do with emotion. When the amygdala speaks, the whole brain listens. Just on the right-hand side of the slide, you see I'm not sure if my pointer is working, but if it isn't, on the right-hand side, you see AMY, which is the amygdala, prefrontal cortex, and the links between the amygdala and the temporal areas and prefrontal cortex are extremely relatively important when compared with some other aspects of temporal lobe input, which I'll show you in a moment. but the amygdala is obviously part of our emotional responses. But I want to concentrate just for 2 minutes on the transformation of the transformation of information from temporal cortex, Heschel's gyrus, etc., to the frontal cortex. And of course, the frontal cortex in the human brain is very much increased in size over all of those the earlier primate brains, non-human brains. But when listening to music, there's also the dorsal stream function. This goes frontally, but the information travels through into motor structures, which are obviously vital in terms of the movement that occurs with rhythm. Now, much of neuroanatomy has been concerned with the gray matter, but particularly with the advent of new neuroimaging, where you can look at lamination of the white matter, there's some very interesting things that are revealed that have to do with music. And this just shows the superior longitudinal fasciculus in the human brain as the extensive connections of the white matter moving here forward from the temporal and posterior areas of the brain. Now, within there is the arcuate fasciculus connecting temporal and frontal lobes. Here's the arcuate fasciculus in the monkey brain and in the human brain. And again, you can see without dwelling on it, the huge differences anatomically in relationship to evolutionary developments. What is fascinating too, looking at the arcuate nucleus here using MRI scans in the chimpanzee below and in the human brain, you see the arcuate fasciculus clearly shown above that line on both sides in the human brain, absent and certainly, if present, slightly misfigured in the chimpanzee brain. So the chimpanzee brain, our nearest relatives, do not have the capacity, the brain capacity, for the music which we gather into our cortex and transmit it to the frontal areas of the brain. They do not have that capacity. And one of the reasons that we can so much enjoy and use music is these very extensive white matter connections. This is just a report showing K448 is a bit of music from Mozart. This was looking at the Mozart effect, but just shows you frontal area responses to music, again, as elicited by brain imaging. And what this says to us, again, is that the information which comes into the brain via all of the subcortical areas I've mentioned, to the temporal areas, to the anterior cortex, the frontal aspects of the brain, where it then gets transmitted backwards into other parts of the brain, and you get a circular movement over millimeter periods of time of the musical input traveling around brain areas. Briefly, repetition and ambiguity are extremely important in understanding why we love music. If you'd actually look at just the Bach score there, it's actually quite thrilling to look at it. But when you're listening to music, how music plays the mind, it's a brilliant book about this, but the repetition is extremely important. But when you think about repetition in music, if you hear the same musical phrase, let's say twice, then the third time there's an ambiguity, and the composers, of course, make use of the ambiguity by not continuing to repeat the same, but by subtly altering what occurs as the music pulls you along. So the mechanisms of brain modification with music could be related to a number of things. One is the alteration of parasympathetic activity. I'll come back to that a little bit in a moment, but you know, it's possible to alter the autonomic nervous system through giving the brain the right music to entrain to. You could be activating cognitive and spatial cortical areas directly on movement, or indirectly via the corticothalamic modulation, remembering that the thalamus and the cortex are closely linked in terms of abnormalities and normalities of the way that the brain receives and acts with sensory input. Signal predictability, I just mentioned, if it's continually predictable, that is one way that by subtly altering what happens, the prediction alters and brings you forward to the next musical phrase. But it could be straightforward entrainment, that the rhythm, the music which comes rhythmically can be entrained into the rhythms of the central nervous system. Some have suggested music modifies the dopaminergic circuitry. There's the issue of kindling, which was a very important neurological or neurophysiological idea in the past. It isn't discussed much. But the spectrogrammatic considerations, in particular the presence of lower harmonic frequencies, which you get in some of the Mozart music, again, may be rather important in terms of other frequencies and harmonies. Mozart's music has a long-term periodicity that may resonate within the central cortex and the cerebral cortex relating to coding within the brain. And this is where, when the music reaches the frontal cortex, it is released to other areas of the brain via what are called corollary discharges. In other words, into limbic structures, which lead to the emotional responses to music. So I'm nearly finished, but I really must talk about raga music. Now, you'll understand that I don't know too much about raga music, but through my visits to a wonderful country and with Krish, we have discussed this. And there's something very special about it from the point of view of how music might be affecting the brain. And if I'm wrong with this, I apologize, but this is what I think I've learned, that the raga music has strong rhythmic components and a set of notes with specific rules and scales. And the raga is holding the scaffolding for a melodic elaboration. Again, that brings in the issue of the repetition and the elaboration of the harmonies within given meter and complex rhythmic cycles. And obviously I know too much about this, but it is based upon ancient Vedic mantras and is well ingrained into the cultural music of your country. Nigel Osborne invented the X system. The X system is of some considerable interest. I don't want to go into it here, except it is a method of taking one form of electrical activity or electromagnetic activity, and in this case, we use the EEG, to turn it into music. It's called sonification. And then take the sonification and change the sonification that comes from the abnormal brain and put in with sonification music which corresponds to the brain rhythms of normality. In other words, we're trying to find music that works within the whole of the brain, the basal ganglia, cerebellum, motor cortex, which can be altered by rhythmicity algorithms. It sounds a bit complicated, which it is, but what we're able to do with regards to music is from the music, take vertical harmonicity algorithms which replicate basic pitch detection in the auditory brainstem, as well as more complex modeling of Heschel's gyrus, with resulting activation of limbic and paralimbic systems. This measures what's called vertical harmonicity. That's sort of up the straight line, if you like, with a chord. But also it entrails linear harmonicity. How do notes and chords follow one another? Modeled with linear harmonic cost algorithm involving limbic and related pathways. So in other words, what we are doing is looking with our system to a piece of music or pieces of music that are able to influence the whole of the central nervous system pathways and activities that relate to that music, and of course, which do relate from a medical point of view to abnormalities in the brain. Just finally, raga music, therefore, could entrain dominant rhythms of normal EEG stage sleep and also the cycles of the awake EEG, which leads us to the possibility that raga music could optimize the EEG by rhythmical entrainment, safe, there are no side effects, inexpensive, culturally accepted. And there's a protocol which we did draw up, which related to the treatment of epilepsy with this entrainment. And the people involved were Professor Dale Hesdorfer, who very tragically passed away just last month. But there was Shantala and Sajid, who were part of this, and we were in Bangladesh at the time. But I think raga music, and Nigel Osborne is very keen on this and composes operas which include some raga music, that this is really a way that might be very important to entrain normal brain rhythms for people, for example, with epilepsy. So I think I'll stop there and need to be rejoined with Krish.
Yes, Prof. If you can stop sharing screen.
Stop sharing screen. Okay. Yeah.
So
okay.
That's the same. The green button.
Yeah. There we are. Yeah. There we go.
And you're back. Thank you so much. That was really fascinating to listen to and to know that so many parts of the brain are involved in music, and both the limbic system and the frontal lobe have a role to play, and of course they have a role to play in human emotion as well, both in the generation and the control of human emotion. I have a housekeeping announcement. People who have questions, please put them into the Q&A box. We're going to try and, as we discussed with Professor Trimble, take as many questions as we can. We have about 35 minutes. I'm going to start off, Prof, by asking you about the field of neuroaesthetics that you have had this fascinating interest in. What is neuroaesthetics?
Yeah, it's a controversial topic, but it was actually, and it's quite a new topic actually, it evolved really because of obviously there's a field of aesthetics which has to do with responses, essentially, I would consider them responses to certain features of our environment, which do relate very much to what we call art. It was Samir, who you know well, who actually introduced the term neuroaesthetics. And it was to join together the field of aesthetics, which has been discussed for 150 years from a philosophical point of view, or even longer, and neurology, neuroscience. And the idea of it is that it is a kind of new discipline. You have to know about your neuroscience, as well as working with people who are artistic and creative. So neuroaesthetics is a branch of aesthetics, which does imply you have to have a rather more, let me say, scientific approach to the discipline. And particularly if you want neuroaesthetics to work on the brain for medical perspectives, it's an ideal way in.
Thank you, Prof. We have a few questions coming in. Very interesting one from Vasilisa Zukova, who asks, why do humans listen to music?
Well, well, they listen to music. But, well, let me just say a couple of things about music. Well, the neuroaesthetics, by the way, is more than just music. There are other aspects to the aesthetics. But there's something extremely important about music. The brain knows music. The brain knows music, and music comes directly into the brain. There are neural codes, and I've just explained to you how quickly and the direction that music goes into the brain, which is totally different from, for example, a picture, because visual input does not go so directly and intimately into the brain The music goes directly in, the sound goes directly in, the brain knows about sound more than anything else. But visual information is always coming reflected into the brain. And also, if you're looking at a painting with lots of different colors and whatever, you know how many different areas that Semir Zeki revealed to do with visual input. It's totally different with music. And of course, the baby, you and I, when we were tiny, it was sound that we had first before we had other visual aspects. So music from sound becomes very important. And again, why do humans listen to music and love music? Because we are mammals, and mammals have mothers. And the first thing that mothers do is introduce you to rhythm, moving, rocking like this, and singing lullabies. And I don't know a culture where mothers don't sing lullabies to their children. So we love it from a very early age.
Thank you, Prof. That's really fascinating. Someone asks about the right brain and music, and I really wanted to ask you about this, that hemispheric dominance, which some of us believed in, especially with, for example, epilepsy and behavior, is not as fashionable today. But is it true that it is the right brain that is concerned with music, or do the imaging studies tell us otherwise?
No, the idea that it's a misnomer to talk about the dominant side and the non-dominant side. And it's sort of an insult, really, to the what used to be called the non-dominant side. In fact, it was Hewlings-Jackson, I think, who recognized that the right hemisphere, if I put it like that, was the dominant feature of a number of activities in the human brain. But I think with music, again, when you look at on visual patterns of imaging with music, if you're looking for, where does pitch come from, where the harmonies come from, whatever, what I've been talking about, those pathways into the brain from exterior music is much more initially absorbed and taken up by the right side of the brain, which we know also is interlinked not with the kind of language that we're using now, making propositional language, but it's more related to poetry and the prosodic view, the prosodic sound of the world around us. And this, I think, is now quite accepted. So I think the right brain should be considered dominant if we think that emotion and things like music are extremely important in the life of Homo sapiens.
Thank you, Prof. There's a question from Melvina, who's a neuropsychiatrist in Kingston, Canada. She asks, one theory is the VNS effect on parasympathetic nervous system. Does volume have any effect on the degree of vagal nerve stimulation that can be achieved? So her question's about volume, but I also wanted to ask you about tonality of music, pitch of music, and the role of the autonomic nervous system, as opposed to the sort of the words that we are listening to when we listen to music. I hope that's not too many questions.
Well, it's a really very straightforward way. The idea of music. You said the words of music. Is that what you said?
Yes, the lyrics.
Well, there's a syntax. I mean, there's a syntax to music, but there's a semantics. When you're reading a novel, when you're reading, again, there's the syntax, and then there's the semantics. But the syntax of music is extremely important. As I was talking about how the alteration of the harmonicity, just a subtle alteration that the composer brings in, opens up this ambiguity. Where's it going next? And so it's a very important aspect that there's something very special about music. Now, when you say the words of music, you have words of poetry. And there is a link between poetry and music, obviously. And there are some people who consider that, well, the first languages that our proto Homo sapiens used was a Musi language. And there's a very well-known anthropologist who suggested this. But the language that we're using now is very much related to the left, so-called dominant hemisphere. And the language that relates to the right hemisphere brings the emotionality and the prosodic nature of our speech together. So there are those differences. But when you said that, I didn't know if you were talking about opera, because, you know, I'm quite keen on opera. The language that goes with music is opera. And opera was well before music became music in its own right without language. So, did that help?
Thank you, Prof. The question also was about an autonomic response through the vagus nerve. And does sound, tonality, or pitch influence that?
Yes. Yeah. Yes, the answer is with appropriate music, you will alter the autonomic nervous system. Now, what the X system does, what we use, actually is directed at the autonomic nervous system through those centers that I was discussing. It's not like, you don't just play nice music. You say, if you like this, you'll like that. Yes, okay, you and I, perhaps afterwards I'll need to relax and I can listen to some music, and you know, if it's heavy beat music, wild music, whatever, it's not going to settle me down at all. But if it's a nice piece of like Bach or whatever it is, it's likely to settle me down. So we know there are tonalities, rhythms, and also loudness and other aspects to do with pieces of music that engage the autonomic nervous system, particularly the vagal effect. So you develop more influence from the vagus nerve, slowing the heart rate, slowing the breathing, and enabling people to relax. But you have to pick music that's going to do that. And people say, well, this is a night, or what tunes do you like? Well, that's all right, but that's not really a very effective way of bringing out a more long-lasting effect in terms of repetition over several days or several weeks, or however people use it. But the autonomic nervous system is extraordinarily important, yes.
Thank you, Prof. And a related question, your book, Sudden Death in the Opera, is it the autonomic nervous system that is involved?
Yes. Well, very quickly, thank you for mentioning that. Is it on sale in India, by the way? I don't know. It's in paperback now. And anyway.
I've not managed to pick up my copy yet, I confess. I've listened to you talk about it, so right. I must do that very soon.
Yeah. Well, what we were interested in was why people die in opera. Now, opera is all about stories, as are novels or whatever. So, and why in certain stories in opera do people die? Well, actually, there's a sort of a expression which says, you know, opera is only a song of love and death. So love and death are very frequent in opera. And the point is that we were very interested to know why certain people died without an explanation. In other words, they weren't murdered, they weren't poisoned, they didn't have tuberculosis, but why did they suddenly drop dead on the stage? And what we did, we reviewed probably something like 50 or 60 librettos where this had happened. And a lot of it is involved with autonomic nervous activity. And seems to be the case that in opera, the women are more likely to die at the end of the opera. Men tend to die in the middle of the opera, or occasionally at the beginning of the opera with an assassination. And it tended to come about particularly in the Romantic era, like they say, the 19th century through to the early 20th century. In the 20th century, men started to be dying in the opera at the very end, unless the women, I don't know what that's to. Anyway, but the issue was that when you went and looked at the librettos, a lot of the characters had autonomic instability actually written into the librettos in terms of heart activities, being pale, fainting, these kind of things. So the death in opera is related to the autonomic activity. But I said the 19th century, but it's interesting, in the 19th century was when the autonomic system was being discovered, and also where certain neurophysiologists were noting the link between sensory input and autonomic activity.
Thank you, Prof. There's a question from Veda. Can you elaborate on how music can trigger a past memory?
Yes. When was the first time you fell in love? What were you doing? The link between our emotional responses to a lot of artistic experiences, but the link is obviously related to autobiographical memory. And with music, this is very, very strong. People who have a sensitivity to music, and by the way, most people have a sensitivity to music. There are some people who are amusical, and I feel very sorry for them. But it's usually, I just mentioned lullabies, but you know, your first love enchanter would have been maybe an equivalent of a lullaby, but at a different age. And music is very, very powerful at stimulating emotional responses. And I don't know if it's the right time now just to mention it, but one of the key features that we have noted that you know about, Krish, was the studies that Dale and I and Robert Letellier and Nigel Osborne did on emotional responses to the arts. And lo and behold, the art that nearly everybody will say they have at some time responded to is with emotional tears. And crying is a definitive sign of emotional effect, but also it's a human effect. We are the only living species that cries tears emotionally. Now, people say, oh, no, I have a dog who does that, or something like that, although this can't be the case. Surely there are, chimpanzees cry, or somebody told me elephants cry. I think we had a discussion about that when I was in Chennai at one point in time.
Yes.
The crying, the tearing, is a very important physiological response. And I know, I believe that I'm correct with this. I even got David Attenborough into a discussion who agreed with me entirely. It so happens that we've just published a paper on that, which has never been published before. It came out yesterday or the day before.
Wonderful.
So the crying is crucial, and the crying is interlinked with emotional moments. And of course, remember, crying is related and permitted, if I put it like that, at certain events such as funerals, christenings, other events that relate to our emotional life generally.
Thank you, Prof. There's a question from Vasilila again, which is academic. What intelligence tests do we do when we are studying music? What intelligence tests do we do when we study music?
Well, I think there are two issues. The issue I think that is a problem there is that the intelligence really comes from people who are musicians, who are much more interested in what the actual score is saying, how it's laid out, how it relates to musical syntax, rather than perhaps to musical semantics. And so a lot of the work that's been written about music comes from scholars who want to discuss the intimacy of the structure of the music rather than the effect of the music on us. And this is where the neuroaesthetics comes in, I think. So, once people started to say, oh, this particular phrase or this particular chord represents sorrow, and this one represents triumph, and this one leads to that. I think once you're trying to tie down music so directly by emotions or whatever, it really doesn't work, because the emotion that you get to music is so different from the emotion that you get when you're angry or you're upset, or the traditional emotions that people study.
Thank you, Prof. It's a question from Alan Alagappan, who's a musician himself. Daniel Levitin's book on brain and music talks about Mozart's effects on the brain.
Yeah.
Any other type of music come up in your research that enhances well-being, creativity, etc.? Is his question.
Well, yes. I mean, the studies that we're doing at the moment with the Xbox basically we can better Mozart, if I can put it like that. And Nigel Osborne we have a repertoire of perhaps 500,000 tracks that the X system can look at to put it in the same sequence that is necessary to alter the brain with entrainment. So we don't find Haydn is of much value. And from my point of view, we don't find that Wagner is of very much value. But there are other musical areas which are largely classical, but don't have to be. And we're talking about raga music here. But at the moment, it looks as if it again depends a bit on the individual brain. There are individual brains that respond perhaps better to Mozart, and which piece of Mozart's relevant, as opposed to people not many people respond to Mahler, actually, for example. So it is related to the composer, but it doesn't have to be classical music, although there's something about classical music which is quite relevant to the story of entrainment.
Thank you, Prof. We have Ludger watching the webinar. He says, very interesting talk. Thanks a lot. He also sends his best wishes and greetings and says, can't speak here. He has 2 questions for you. Is there a specific response of the brain towards harmonic versus disharmonic music? Or to put it in other words, between music and noise, is the first question.
Yes, hugely so. People have done studies going back into looking at animals in the wild and the kind of things that anthropologists can do or whatever, showing which are the sounds which lead animals to freeze, to be frightened. And basically, they're ones which are atonic or are actually causing chaos to harmonicity. And one of the things which has happened with a lot of modern developments of music has been not to use the atonality or not to use the structure of the music, allowing resolution of the disharmonies, but protracting the disharmonies to such a level that a number of people find it very disheartening. And thank you. Look at how nice to know you're there. We often had these discussions, and he's of course written a new book again on philosophy, which is very much a part of the neuroaesthetics, really. But I think the issue is that if a composer deliberately composes to make people feel uncomfortable, then what's the point? I mean, we live in a very difficult world as it is. And actually, when when modern operas, for example, are deconstructed and their original meaning is lost, what happens is the audiences won't come. And if the audiences don't come, then, that'll be the end of a lot of important music. Yeah.
Thank you, Prof. His next question, in fashion, the emotional response to given signals, be it clothing or music, changes. Can we understand this in terms of brain activity?
I'm not quite sure the question. Can I just say one other thing about what I just said about the noise? Because infants, very, very 2 or 3 months old, will listen to harmonic sounds and shy away from the disharmonic sounds, and which cause distress very early on. we pick up harmonies. Sorry, could you just repeat that last question about?
So Ludger was trying to ask, in fashion, things change.
Oh, fashion.
Yes.
I thought there's.
And,
Are we
and
talking
like
about?
that
Are we
in
talking?
music? Sorry, boss.
Yeah.
Sorry.
Yeah.
Please go ahead.
Fashion in music changes.
Okay, does that have an effect, or does that have an impact?
Well, yes, and because the fashion often has changed because of the development of musical instruments, the development of singing, and I mean, what happened was the development of the sonata form and also symphonies and quartets. The development of those different genres of music, yes, has made a big difference. But the idea that one has to continually take them to a level where they actually put people off listening to the music because it is so difficult for the brain to absorb the chaos of the input is a problem, I think. And I don't know, shouldn't really say this, but I think one of the worst things that happened to music was the development of the electric guitar.
Prof, we have an interesting question from Suchitra Narayan. How do deaf children perceive music and even appreciate music?
I really think I have no answer to that. And if I said they didn't, then that would be beyond my pay grade, so to speak. I think the field of neuroaesthetics does look at this issue. And I have been in seminars with deaf composers. And they do that because they can see, and looking at that, like that Bach image I just showed, they can see what the music looks like from the score and somehow begin to understand that. And also they can understand the touch and the rhythm. So I think they are in a different world emotionally, I imagine. But if you said to them, oh, look, you really don't understand music at all because you can't hear, I think they would say, well, therefore you're quite wrong because we can. And as I say, there is a department, I can't remember where it is now, but in England, which deals specifically with deaf people in music.
Thank you, Prof. Nagraj Halimani would like to know, what about the neural correlates of music of songbirds? It could be part of their courtship behavior, but the music in humans seems beyond just courtship behavior and the evolution of neural correlates built on the same.
No, it's a fanciful issue. It's very relevant. Songbirds have more than just making tunes that we have. I mean, they are bipedal. We are bipedal, and they do have not many, but a number of species do have very close attachments, which can be lifelong, and they do sing harmonic music, as we think, to each other. But often this is, and some are creative within the species, but the idea that they actually get the same emotional responses that we do, I don't think is valid for the various points that I've been talking about. I mean, it's lovely for us to listen to them. Whether they listen to us, I don't think they do, really. If we have music on, I don't think they listen to us, but parrots do, maybe, and whatever, pick up, human intonation. But it's a parallel evolution that the vocal sound of music has progressed as it has.
Thank you, Prof. There's a question from Juan Manuel Orjuela. New artistic abilities have been described in some people with dementia, mainly at a pictorial level. Have you seen cases of patients who develop or improve musical skills associated with neurodegenerative diseases?
Not particularly, but I think, I'm sure that, gosh, I can't, no, the answer is I haven't, no, I really haven't, but we've seen people with degenerative diseases developing poetic skills, if that's of any help, but I can't think about musical skills. Oliver Sacks, I think, wrote up the case of a man who certainly had a bad head injury and then was said to be able to play the piano and never had played it before. I liked Oliver Sacks. He was wonderful. And but whether I should take that with a pinch of salt, I'm not sure. But he did. It's in his Musicophilia, I think. Yeah.
Yes, it's in Musicophilia. You're right, Prof.
Yeah.
There are two interesting questions. One from Srivatsa, who asks, about music transporting people into ecstatic states of being. And are there specific brain areas involved in that?
Yes. I mean, the answer is it's like taking a drug, isn't it? Music used in a religious sense, and I don't necessarily mean by that it has to be in a temple or a church or whatever, but music in a kind of religious sense does transport you into a transcendental state. And by the way, that's very common in the romantic operas. Tristan and Isolde, why did Isolde die? Isolde sung herself to death in a translational sense. So I believe very much that our brains are capable of a different appreciation of the world that we live in. This is what aesthetics and the art really are about. And I think that music has that ability. And close your eyes or whatever. And but some people talk about it as if it's a drug. In other words, this is something that transports them. And of course, a lot of modern composers use drugs, particularly cannabis and others like that, and whatever, in order to create, particularly I think probably in the jazz world. So, but yes, I think music does. Whereas paintings, I'm not sure that they do that. But music is different.
Elvina, another interesting question. Does the operatic effect only happen in Italian because of the linguistic characteristics, or is it cross-cultural?
So the what effect? The opera effect?
The opera effect, the operatic effect.
The effect of transcendental state. You mean the deaths in opera? Is it to do with that?
I think Elvina means the impact of the opera on human emotion. Is it language dependent?
I don't. Well, that's interesting. I'm not sure it can be language dependent because what I call Western music and Western opera is extremely popular actually in China, but in Japan, where you are too. So the actual language isn't so important as whatever is coming out, being spoken, is in somehow sympathy with the music which is being played. But as you go to the much more to the late Baroque and into the Romantic era, the composers more and more were composing music with less reference to the actual libretto. I mean, the libretto was important, but a number of composers, of course, decided they were going to write their own librettos to make sure that the music that they wanted to compose fitted or had the libretto which fitted it completely. And the number of people did that, like Puccini and Wagner, of course, and a number of others. So the later idea was that the musician, the composer, wanted to be the top, if you like, for the opera.
Thank you, Prof. There's a question from Jyotsna Vadivel, who asks, as a chromesthetic person, sound, visual, synesthesia, can you explain what is the logic of my seeing colors and shapes on hearing certain notes or sounds? I'm a pianist and I can see colors in my head when I hear a chord or a note. I'd be really happy if you picked this question to answer.
I'm grateful for the question because it sounds as if you really do have synesthesia. I meet people say, "Oh, I have synesthesia," as if it's something sort of really important and strange and nobody else has it. And then you ask them, what do they mean? They say, "Oh, well, yes, the sound. When I hear the sound, I think of blue." I said, "Well, no. It's feeling the sound giving you the color." And I think, of course, synesthesia exists. Many more people claim it than actually have it. It sounds as if the questioner really does have a synesthesia. I don't think it means you're neurodiverse, if I can put it like that. But I think it's important in certain creative artists, pictorial artists, who appeared very much to have this kind of effect, particularly some of the German 20th, early 20th century painters developing expressionism, well, and impressionism too, I think.
Thank you, Prof. And there was a related question earlier, which asked about visualizing colors along with music, meaning, for example, there are sort of apps that show you sort of a series of colors or color images as you are listening to music. Does that kind of ability to sort of to be able to visualize like that, does that have an impact in any way?
Well, no, but I can't see the point of it. I mean, in a sense, I say, the direct sensation that takes you into the outside world is sound, and as soon as you have different visual inputs, which are reflected rather than direct, then I would think that would be a distraction actually to listening to the music, particularly if you wanted a transcendental state. Now, I'm not going along with that if it's somebody who likes to take, their cocaine or their whatever's the new drug around, where you do get a dislocation of time, space, and color. Dangerous though that is.
Thank you, Prof. My sister Aparna has this question. She says, I have trigeminal neuralgia. I've noticed that when I have pain, I find it difficult to speak, but easier to sing. The pain recedes. Why is that so?
Well, I think you should in your clinic, you should be trying this, because it's a very unpleasant condition. And I have no answer to that unless it's a neuromuscular thing, as opposed to the actual the sound that you're creating. Well, there's an experiment for you to set up there, Krish.
Thank you, Prof. There's a very interesting question here from Ganapati Krishnan, who asks whether rock music, and he names Freddie Mercury, Mick Jagger, Bob Dylan, and so on, and so other forms of music, would they have the same effect on humans as Mozart, Bach, and so on?
Well, again, it is an individualistic matter, but I think if you wanted to achieve, let's say, an alteration of the parasympathetic activity, it really wouldn't be the way to go. If you wanted to alert somebody who is in a different emotional state, then they would certainly have music that relates to that. And of course, I don't want to be too harsh about it. I grew up, as many people in the audience did, with actually very lovely harmony, romantic music. But things happened after the wonderful Beatles came the Rolling Stones, and came even more use of the electronic guitar and electronic everything else. So I think the music, I think it's very important and also the other problem with current rock music is people go to these concerts and their ears, I'm afraid, will all be damaged badly with the loudness that is so important, and I don't understand it. A lot of young people don't want to talk to each other anymore, and they will have tinnitus. And I think I don't know if you've noticed this, Chris, just generally in population, but it's very sad that some of this music is played at such a loud level that it will be very damaging. Yeah.
So not all music is possibly beneficial in the same way, but it's personal choice as well. We've had several questions asking about music as a treatment for depression, for epilepsy, of course, the question on trigeminal neuralgia, for cognitive enhancement. Your comments on that?
Yeah, no, I think the electronic era which we're in now is bringing about a lot of, if I say non-invasive, that's really what people are looking for. I mean, obviously, if you have bad Parkinson's disease, you can have some intracranial treatment in various areas of the basal ganglia, etc. There is work going on with music therapy for people who have aphasia, strokes, again, stimulating various parts of the brain, trying to alter the activity within the cerebral cortex, allowing people to regain prosodic language back to the music and the right brain again. We're doing epilepsy in this way, using just brain stimulation, but not transcranial magnetic stimulation or vagus nerve stimulation. Although, you know, I've been involved in both of those modalities. But altering the brain, altering the parasympathetic sympathetic balance, I think is very important in people with who've got dysautonomic systems. But it's not just playing nice music. You know, do you like this? Well, we'll play it again. It's actually delivering music that will alter the parameters within the central nervous system that will increase parasympathetic tone. And I think that must apply to people with panic disorders, whatever. Depression, I'm not sure about. People say, oh, I feel much better now, and they go away. But will they actually continue that same piece of music or whatever? I'm not so sure about. But more with the autonomic nervous system, the anxiety disorders, panic disorders, post-traumatic stress disorder. These are all avenues where brain stimulation can be used perfectly safely, really.
Thank you, Prof. I have a rather complex question from Sonal Chitnis, who's a speech and language expert, but I'm going to ask her to email it to you because I really do. I think it's too complex to ask in a webinar.
All right.
She's of course talking about language and prosody and music. So I will connect her with you on an email.
Okay.
Prof, I think we've still got a few questions, but I think our hour is up, and I think we should let you go. But it's been a wonderful talk and a wonderful discussion today on music, and I'm sure all of us who have tuned in are enriched by it. So I'd like to say thank you very much on behalf of our whole team at Buddhi Clinic, but also my family, and I think it's a great tribute to my late father, whom you knew well.
Of course, yes. And say to your mother, I remember warmly many occasions. But are we going to see you anywhere over this part of the world? Are you coming to the neuropsych meetings at all?
I will try and connect with you, Prof, in the coming months when I travel there. So perhaps we can continue talking after we've said goodbye to all our viewers today.
Of course. Well, thank you for the invitation. It's been great fun. Just a pity I can't see everybody. It would have been the biggest audience I've ever had, I think.
Thank you, Prof.
Okay.
So I'm going to ask sort of the host to sort of terminate the webinar. I'd like to thank the audience for being here. It's been great fun, and I'm sure we've all learned so much today. Thank you.
Okay. Thank you.
Prof, we just stay on. We can.
Okay.